Question number 33. Okay, you've got two triangles, got lots of information given about each of these triangles. So have a look at the first one. It's an isosceles triangle. Okay, so you need to know the facts of an isosceles triangle. What that means is there are two angles which are the same size, and there are two sides which are the same length. Okay, so from that you know that these two angles are going to be the same size. Okay, then you've got an equilateral triangle. Okay, the easiest way to remember this one is equal. So your equilateral triangle, and that means all the angles and all are the same size and all the sides are the same length. Okay, so all the angles in a triangle add up to 180 degrees. It's important that you know that fact. Okay, so before you start any working out in this question, you need to know the angles in a triangle add up to 180. You need to know the properties of an isosceles triangle, and you need to know the properties of an equilateral triangle. So again, you can see how important your facts are and how much you need to know them. Okay, so with an equilateral triangle, three angles, they all add up to 180. So each of those angles is going to be 60 degrees because 180 divided by 3 gives you 60. So you can label those 60 degrees. Okay. If you have a look at your isosceles triangle, this angle plus this angle plus this angle equals 180. So we need to work out the size of angle A. It's going to be exactly the same as this angle over here. So your first step is to take away the size of the angle you already know. So 180, and we're going to take away 34. Okay? That gives you 146. Now that means this angle and this angle equal 146 degrees. Okay, so with an isosceles triangle, we've already worked out that those angles are the same size. So to work out what they actually are, we're going to divide 146 by 2. Okay, so 1 divided by 2 is 0. Carry over that 1. 14 divided by 2 is 7. Okay, 6 divided by 2 is 3. So this angle is 73 degrees and that angle is also 73 degrees. So you still haven't got to the answer yet. The question is asking you how many degrees is angle A greater than angle B. So angle A is 73, angle B is 60. So we're going to think about 73, take away 60, and that gives you 13 degrees. Okay, so angle A is 13 degrees bigger than angle B. Question number 34. You've got some information about athletes and how far they were able to throw their javelin. Okay, so I've written them out colour-coded for you so that you can notice that 2 are in metres and 2 are in kilometres. So to work out who threw the farthest, you need to decide whether you're going to convert this and this into kilometres or this and this into metres. Before you do that, you need to know a fact. Okay, the fact is that there are 1,000 metres in a kilometre. So I'm going to change the 2 kilometres into metres. So to convert from kilometres to metres, we multiply by 1,000. So what I've done down here is I have written out my place value chart. So my tens, my units, my tenths, my hundredths. Okay, we've got 0.06, which is how far Chris threw. So we're going to convert that from kilometres into metres. So we're going to move every digit 3 places, going 3 places because we're multiplying by 1,000 and there are 3 zeros. So 3 places to the left because it's multiplying and the number's getting larger. Okay, so we're going to go 1, 2, 3 with our 0. Okay, 1, 2, 3 with our other 0. We'll have a talk about these wee zeros in a minute. And then our 6 is going to go from our hundredths into our tenths into our units, units into our tens. Okay, now you've got units here. We've got no units in this number, so we need to pop a 0 in there to show that. Decimal point doesn't move and we've got no tenths. Okay, so we don't actually need these zeros anymore, and we can now see that 0.06 kilometres becomes 60 metres. Okay, so I'm going to pop the 60 in here. 60 and 60.0 are exactly the same, so it doesn't matter what way you write it. Have a look at Joe's distance, so 0.057 kilometres. We're going to multiply that by 1,000. I'm going to do this one slightly differently. Okay, so we've got these 2 zeros here. Because we're moving 3 places. I'm just going to leave those and I'm going to start with the 5. Okay, so we're going to go 1, 2, 3, pop our 5 in here. 7's going to move 1, 2, 3 places. A quick wee point there, the decimal point is not a place, so you're not going 1, 2, 3. Your 7's not going in here, okay? It's going from the thousandths to the hundredths to the tenths into the units. Your decimal point doesn't move and we've got no tenths. Okay, so 0.057 times by 1,000 gives you 57. If you had have moved your zeros, they just would have been in front of the number there. Okay, and we don't need to worry about them. If they were here in the middle of the number, you would need to include them. So that one, Joe, his is 57 metres. Okay, so now it's much more straightforward to work out who threw their javelin the furthest. So we've got 56, 60, 57 and 57.3. Okay, so you can see very clearly that Chris threw his javelin the furthest. Question 36, you've got 3 vertices. Okay, vertices are your corners, okay, of a shape, of a parallelogram, and you're shown in the dots in the grid below. Okay, so 3 possible points. For the 4th vertex is just the singular form of vertices, can be drawn on the grid. You need to write the coordinates of the 2 points in the spaces below. Okay, so if you want to join those up like that, okay, and then you want to finish off your parallelogram. So if you were to join there to there, first option for the vertex to complete the parallelogram would be 9, 9. Okay, so if you go up, it's 9 across and then 9 here. For option number 2, okay, if you join this line like this, okay, this one here, okay, and then you've got 1, 2, 3, 4, so you're going to go 1, 2, 3, 4 across here to give that point. Okay, that would have made another parallelogram in this area. So your next option was 1, 9 for this point. Okay, and then your last option of the way to draw your parallelogram is to draw a point down here. Okay, so join these 2. Okay, join these 2 and then down to there and across to there, and that would be 7, 1. Okay, so your 3 answers are 9, 9, okay, which would be this point here to make this parallelogram. Okay, 1, 9, which would be this point here to make this parallelogram. And then your last one would be 7, 1 to draw a point here to make the parallelogram outlined in red. Question number 45. You've got 2 calculations, okay? I'm just going to show you very quickly a wee tip to answer these questions. So 8 squared, I would write 64 below that straight away, okay? Change your calculation to 64 plus 31, and then it's a very straightforward addition calculation. 6 squared is 36, so again replace the 6 squared with 36, and then you've got a straightforward subtraction calculation. You need to know your square numbers for that question. So on question 46, we've got some blocks, okay? It shows you the size of them and the length of the different measurements, okay? So Anne uses the blocks to build the structure below. It has 2 layers of black blocks and a layer of white on top. So this is your black here, and then this is your white. Okay, so from this you know that the black blocks, these little bits here, measure 1 centimetre. So that's 1, 2, 3, 4. So that's how I've been able to work out the length of that part. Okay, 4 centimetres. If you have a look here, these 2 are also black, so that's 1, 2 centimetres. Okay, the height of your cuboid, this is made up of 2 black blocks and then a part of a white block. So this is 1, 2, okay, so your black is 2, and then you've got this part here, which is this part of the white block, okay, and it's 0.5 centimetre. So the measurement of the height of the cuboid is 2.5 centimetres, okay, or 2.5 centimetres. Once you've worked that out, and definitely write it onto your paper, okay? It's fine to write anywhere on your paper as long as your answer is in the clear answer box. It's really important to do your working out, and it also helps you whenever you come to check. So it's not really a sensible idea to do your working out anywhere else on the paper, but on the page that the question is on. Okay, so when you come back to check, the working out is right beside where you have answered the question. So you need to now work out the volume of the structure. Okay, so remember your volume is your length times your width times your height. Okay, so you've got 2.5, 2 and 4. Okay, so I'm going to start off with 4 times 2, which gives me 8. Okay, and my next step then is to do 8 times 2.5. Okay, so I'm going to switch that around. I'm going to put the 2.5 first, and I'm going to multiply it by 8. Okay, so multiplying decimals. Remember 2.5 times 8 is exactly the same as 8 times 2.5. So 5 times 8 is 40. Okay, 2 times 8 is 16 plus 4 gives me 20.0. So your answer is 20 centimetres cubed. Question 47. Okay, you've got some information about hot dogs. You need to work out how many pupils did not have relish on their hot dogs. So if you look at the 3 circles, these pupils in here had ketchup and mustard, because that's the ketchup circle and the mustard circle overlapping. Okay, these pupils here had mustard, ketchup and relish. Okay, pupils in this, where these 2 circles overlap, had ketchup and relish. And then in this part, they had mustard and they had relish. Okay, so you need to work out how many did not have relish. So if you look at the relish circle, okay, you're not thinking about any of those pupils. So it's these pupils here. So you've got 3, 6, 7, 8 all together. Okay, question number 48. Okay, I've got some information about somebody who's facing east. Okay, so we're going to start off facing east. They're going to turn 135 degrees anti-clockwise. So remember, clockwise is that way. Okay, anti-clockwise is that way. 135 degrees. Okay, so these are your right angles. So each of those are 90 degrees. And this is half a right angle. So that would be 45 degrees. Okay, so what you're going to do is you're going to turn from here, anti-clockwise. So you're going to turn through 90 degrees. Okay, another 45 degrees is going to give you a total of 135 degrees. So you're going to be facing northwest. Question 49. Okay, you've got 10 numbers and they show the number of rubbers in the pencil cases of some primary school pupils. So you'll know yourself, any of you have no rubbers, some of you have 8 rubbers, some of you have 3 rubbers, some have 5, some have 2, all different amounts. Okay, so what the question wants you to do is to work out the average. So that to find the average, you add all the numbers together and divide by how many you have added. Okay, so let's have a look at the easiest way to add these together. I'm going to look for the number bonds to 10. Okay, so I'm going to add 6 and 4, which gives me 10, and I'm scoring those out so I don't add them more than once, and you can do that on the paper. Okay, 7 and 3 gives me 10, so that's another 10. Okay, 8 and 2 gives me 10, and then I've got 5, 6, 7, 8, 9, 10. So it makes it a very simple calculation, 10, 20, 30, 40. So the total of those numbers is 40. Okay, now the next step to find the average is to divide that by how many you have added. So you've got 10 numbers. Okay, so 40 divided by 10 is 4. So your average number of rubbers is 4. In the next part of the question, question 50, you have to work out the range. Okay, so the range is the difference between the largest and the smallest number. The way I try and remember the range is like a driving range in golf. You're hitting the ball from one end as far as you can to the other end. So from the smallest to the biggest. Okay, so you have to find your smallest and your biggest number. So your smallest is 0, your largest is 8. Okay, so we're going to do 8 take away 0, which gives you 8. So the range in that set of numbers is 8. Question number 51, you've got a pie chart We had a wee look at this a couple of weeks ago. It was a bit more straightforward than this one is, so we'll have a good look at this one today. So the pie chart shows 120 children, okay, and it's told you that the number of children who prefer cycling is 12. So that means this little slice of the pie chart stands for 12 children, okay? 3 times as many prefer football. So if you do 12 times 3, that gives you 36, which tells you that this part of the pie chart, the football part, shows 36 children, okay? You then need to work out how many prefer swimming. So you don't know yet how many prefer reading, and you don't know how many prefer swimming, okay? This right angle is really, really, really important for you in this question. So a right angle is a quarter of all of the angles within this circle, okay? So that means it stands for a quarter of the total number of children the pie chart represents. So if you have a wee think about that, you want to work out 1/4 of 120. Okay, so to work out a quarter, we divide by 4. So 120 divided by 4 gives you 30. So that means that this part of the pie chart, which is a quarter, is 30 children. Okay, so your next step now then is to look at these 3 and add them together. Okay, so we've got 30 plus 30, which gives you 60, plus 6 is 66, plus 10 is 76, and then plus 2 gives you a total for those 3 of 78. So your last step then is to work out how many children chose swimming. So if you had 120 altogether, these 3 parts of the pie chart stand for 78. Your last step is to do 120 take away 78. And that gives you 42. So 42 children chose swimming.